Hey, welcome back. So we are going to have a lot of fun in this video. We are going to bring together the power of large language models, agents, function calling, retrieval augmented generation, and WebAssembly. That's right. We are going to dynamically load a WebAssembly function. We're going to find that function using retrieval augmented generation, and then we're going to have our AI agent execute that function using function calling. And if you're wondering why, I think WebAssembly is going to become the de facto way of doing function calling and tooling within AI. And the reason is it's secure by default. I can dynamically load a WebAssembly module, I can access the functions, and by default, it is pretty secure. It operates within a sandbox environment. It doesn't have access to things like networking. It doesn't have default access to the file system. These are things you need to give permission for WebAssembly to use, which is inherently safer than executing a native function such as Rust or Python within your local machine. And I think the possibilities become endless. And not only that, WebAssembly is a lingua franca tooling language. So I can write my code natively in something like Rust, or I can use something like AssemblyScript or C, and then I can compile down to WebAssembly and have it execute in that environment. So we take away the complexity of which language you're going to execute. And as I said, much safer than running things like Python scripts. So to get started, the first thing we're going to do is we're going to create ourselves a nice little simple AI agent. I'm going to just create a folder called Hello Agent. We'll just CD into that. And the framework that I'm going to use today is LlamaIndex. I know in other videos I've used LangChain, but because I'm doing retrieval augmented generation towards the end of the video, I think it's easier to use LlamaIndex in this case. So I'm just going to do a pip install LlamaIndex, and that will get that installed on my machine. Now that's installed, I'm just going to bring up Visual Studio Code, and I'm going to create myself a new directory called tools, which is where I'm going to define some default tools to begin with, and then we'll switch that across to WebAssembly later on in the video. So the first tool that we're going to create, we'll just add two numbers together. We'll call it add tool, and I will put that in my tools directory. To define that tool in LlamaIndex, I just need to import LlamaIndex.core.tools. And because we're going to be doing function calling, I'm just going to do import function tool. And then after that, I just need to define my function as normal. So I will just say def add. We're going to have a parameter called A, we'll have a parameter called B, they are type integer, and we're going to return ourselves an integer there. I'm going to give it a nice little description which says add two integers and return the result. And if you saw my other video on how to create React agents, you will know that this description is vitally important, because actually that is what the tooling frameworks are going to use to be able to understand what this function is actually doing there. And then, of course, I'm just going to return A plus B. Now that I've got my tool defined, I just need to call, now that I've created my add function, I just need to define my tool. So I'm going to create something called add tool, and then I'm going to set it equal to function tool. And then I'm going to do a from defaults, and then I'm going to pass in the function. So it's going to be fn equals add. And what that's going to do is wrap up a nice little function calling procedure that LlamaIndex will use when we define our agent. Now that I've defined that, I'm going to create one more tool, and it's going to be called multiply. So we'll just copy and paste this. We'll call it multiply. And then with the multiply tool, all I'm going to do is change the word add from to multiply. We'll change the pedantic description there as well. And then we will just do A multiplied by B and change the function name. So we now have two tools. For easiness sake, I'm going to use OpenAI today. I'm going to use specifically the GPT-4 only model. So that means I'm going to do a pip install LlamaIndex LLMs OpenAI. In a future video, I will do this with something like Mistral, because that now supports function calling. But for this video, I'm just going to use GPT-4o. Now that it's installed, I am just going to create myself a nice little .m file, and then I'm going to put in OpenAI API key, and then I'm going to put in my API key within there. So if you want to know where you can get your API key from, you just need to bring up a browser. So I'll bring up Brave. We go to platform.openai.com, and then I can just click on API keys, and I can create new secret key, put in the name there, and then all I'm going to do is copy that within there. Now that I've pasted in my OpenAI API key, I can now create my agent. So I'm going to create a file called agent.py. And the first thing I'm going to need to do is actually load those environment videos. So I'm going to use .env, and I'm just going to do a load .env in there. The next imports that I need to have there is actually the OpenAI agents there. So I'm just going to do from LlamaIndex, and I'm going to specifically have .agent and .openai, and then I'm going to import OpenAI agent. And then obviously I am going to need from LlamaIndex again, and this time I'm going to have LLMs, OpenAI, and I'm going to import OpenAI. So that allows me to use an OpenAI agent, and I'm going to be using the OpenAI LLM so I can use GPT-4o. Next thing I need to import is the tools that we just built a second ago. So I'm going to do from tools .add tool, and then I'm going to import add tool. And then I'm going to do from tools .multiply tool, and we will import multiply tool. And as you can see, I've got a little bit of issue with multiply tools not accessed. So if I just come back into multiply tool, I just need to change that add tool to multiply. Let's just save that and come back into our agent. Okay, so now that I've got my imports in place, I just need to load those environment variables. So I'm going to do that by doing a load.env. I need an LLM, so I'm going to say LLM equals OpenAI, and I'm going to pass the model is going to be equal to GPT-4o. Next thing I need is an agent, so I'm just going to say agent equals OpenAI agent. I'm going to do that from tools, and then I'm going to pass in the list of tools that I want to include. So in this case, I'm going to have my multiply tool, and I'm going to have my add tool. I'm also going to need to specify an LLM, so I'm just going to say LLM is going to be equal to LLM, and as you can see, that is GPT-4o specified there. And then I'm going to switch on verbose so you can just see what's happening on underneath the hood. And now that I've got my agent defined, we can actually just ask a question of it. So I am just going to say agent.chat. And the query I'm going to have is what's 25 plus 5 multiplied by 2. And then we will just print out the response. The reason I'm picking that as a query is what I want the agent to be able to do is recognize that it needs to do an addition, and then it is going to use the add tool that we defined. And then I want it to recognize that it's going to use a multiplication, and therefore it's going to use the multiply tool. So if we just save that for a second, and I do a Python agent.py, you can see verbosity, added user message to memory, what's 25 plus 5 multiplied by 2. So the next part that you can see there is going to call a function, and it's going to call the add function. So it recognizes that it needs to add 25 and 5 together. It's recognized the parameters A and B from our tool. And then it's added them and got the output 30. And then once it's done that, it recognizes it needs to do the multiply by tool and knows what the arguments there, A and B, and it's passed in 30, which is the output of the add. Passed in the 2, and then it came back with 60, and it says the result is 60. So it's used 2 tools, and the agent came back with a pretty good answer, which is awesome. And that is function calling. But that's not going to be enough for us because that's just using standard Python tools. And as I said, we are going to use WebAssembly. So to do that, we are going to use a tool called AssemblyScript. And AssemblyScript is a really simple language, kind of like TypeScript, which will generate WebAssembly. Now, in all honesty, you could use other tools like C, you could use Rust, and you can use whatever tool you want. But I find AssemblyScript is pretty simple, and it's quite reflective of the WebAssembly that I want to generate. So that's why we are going to use that today. I have a whole video on AssemblyScript. I have a ton of videos on WebAssembly, so feel free to go and check that out, where I go into deep details of how WebAssembly works. But for just now, we're going to make this super simple. So I'm just going to create a new directory called hello AssemblyScript. We'll cd into that. I'm just going to do an npm init. That will just create me a nice default Node.js project. And what you will see is I have a package JSON off the back of that. And now what I need to do is install AssemblyScript. So I'm going to do an npm install. I'm going to install it as a dev tool, and I'm going to use the package AssemblyScript. So we'll just put assembly script. And you can see that has now created a nice little package JSON, and their AssemblyScript is now a dev dependency within that. What I want to do now is just scaffold up a really simple AssemblyScript project. So I will just do npx as init and then dot, and that will now essentially create me a nice little AssemblyScript default project. And you can see there, now if I look at this, I've got an index file, I've got some out-of-the-box AssemblyScript. So here is an add function, which takes 2 numbers, adds them together. And then I can do the same for multiply, etc. So if I want to compile this piece of AssemblyScript, this add function, into WebAssembly, then I can simply run within AssemblyScript npm run as build. And then it will take that nice little index.ts that we see here. And then if I go into the build folder, you will see it's now created me a nice little release.wasm. It's also created me a debug.wasm, a .wasm file as a WebAssembly file. It has actually also created a thing called WAT, and that which stands for WebAssembly text format. WebAssembly text format essentially allows you to have a sort of Lisp type language which defines a function, and then what happens here is you could then take a WebAssembly text format file and then compile that down into WebAssembly or a WASM file. And as you can kind of see here, this is the WebAssembly text format representation of our add function. So you see export add, and then within there you can kind of see a function definition. It's got two parameters, parameter 0, parameter 1, both of int32. And then you see here it does a local.get0, so it takes that first parameter, so it just pulls that. It's a stack machine, so we'll actually push that onto the stack. And then it'll take the second parameter, push that onto the stack. So we have two parameters on the stack, and then it will just add two items on the stack together. So, you know, in this case, parameter 1 and parameter 2, and then it will perform the calculation, the addition, and then it will push the result back onto the stack when you come out there, and that will give you the result. That is really what's going on in this WebAssembly text format. I have a very detailed video on how all of this works. Go feel free to check all of that out. But now if I just clear this and then I do an npm start and then click on localhost 3000, you can see this number here, 3. So it's actually done a calculation of some sort. So let's just come back into VS Code for a second. You can see I've got an index.html where it's adding two numbers, 1 and 2. If I change that to 10 and 20, hit save, and then we come back into our browser and I refresh, you can see it comes back with 30. And what's actually happening underneath the hood here. And if we just look under the hood of this release.js, you can see all it's doing is loading up that release.wasm. It's actually exporting the add function that we created within there, just as a normal JavaScript function. It can be called as normal. And then essentially it's going to compile and allow you to execute it. So there's nothing more complicated than that. If I wanted to, I could extend the functionality. So I could take this add function, and I could actually create ourselves a nice little multiply as well. So we'll just put in multiply, and then rather than doing a plus b, we'll return a times b. And then if I come into index.html, I can import multiply as well. And then rather than calling the add here, I can do the multiply, which will now do 10 multiplied by 20. Of course, what I'm going to have to do is do an npm run as build one more time, and then I can do an npm start again. We can then click on localhost 3000 and you can see it's done the calculation. So the answer there is 200. And then if I come back in here, you see it's multiplied 10 and 20. So it's fairly simple to do things. If I wanted to, I could actually even manually create the WebAssembly. So I'm just going to copy the release.wat and I'm going to change the name to math.wat. And then in the same way as I've got this add and this multiply, what I can do here is I can add a new function within there. In this case, I'm going to call it square. And then rather than having in two parameters, I'm just going to have one parameter, which is parameter 0. And then rather than kind of remember the pushing onto the stack. So I push the first parameter onto the stack, and then I'm going to push the second parameter, and then I'm going to do the multiplication. Well, actually, I've only got one parameter because it's a square function. So all I need to do now is just push onto the stack the parameter twice, and then I can do the multiplication as I did before. And then if I want to, I just need to do another export here. So in the same way as I've got an add and a multiply, I just need to add a square now, and then I could put square here. So this now gives me my manual WebAssembly text format, but I need to convert this into a WebAssembly module, a WASM file. So to compile that, I will need a tool called WebAssembly Binary Toolkit, or WABIT. And all I need to do for that is just do a brew install WABIT on my Mac, and then that will download that for me. And of course, if you're not running a Mac or you want to install it manually, you can just go and look up WABIT on GitHub. You can pull it down locally, and then you can make and build it on your local machine. Now that that's installed, I have access to a tool on this called wat2wasm, which takes a WebAssembly text format file and converts it into WebAssembly module format. So I am going to take this from my build, and I'm going to take the math.wat. I'm going to have a -o, which is, I'm going to specify my output file name. And in this case, I'm going to build something called math.wasm. And if I come back into Visual Studio Code, you're going to see there's this math.wasm file that has been created. Now all I need to do is, if I go into my release.js, rather than loading release.wasm, what I could do is change that to math.wasm. And now if I do my npm start one more time, as you see, it's still loading 200 there because it's still accessing the multiply function. It's the same function that I used earlier, but of course that is now in my math.wasm as opposed to the release.wasm. So you know that that's actually worked. But if I want to test out my new square function, all I need to do is go into index.html, change this to square, and I'll just add square into the list of functions that I am importing. And now I just need to change, rather than passing in two parameters, 10 and 20, I will just pass in, let's say 5, and the square of that should be 25. And then finally, I just need to come back into release.js, and then you see the export here, export add and multiply. I just need to add square to this list as well. And now I can do my npm start. Click on localhost here, and as you see, 25 has now appeared. And of course, if I come back into VS Code, come back into my index, and if I want to put square of, let's say, 7, I can just come back into my browser one more time and do a refresh, and I've got 49. So now not only can I create WebAssembly using something like AssemblyScript, I can also create it manually using WebAssembly text format. But of course, you can always use something like Rust or C if you want to create WebAssembly as well. So now that we understand that, one of the things I need to be able to do is load my WebAssembly using Python. So to do that, I'm going to come back into my Hello Agent folder, and I'm going to install a thing called wasmtime, which is essentially a runtime for WebAssembly that you can run on the back end. So if I just pip install wasmtime there, that should be installed. So now what I'm going to do is I'm going to take this math.wat that I created earlier, and I am going to copy this into my tools folder on my Hello Agent project. So I'm just going to paste that in here. So it said, do you want to paste that? And now my math.wat is now part of my tools folder in Hello Agent. So now what I'm going to do is I'm just going to call that WebAssembly that we created from Python. So we will create a new file. I'm just going to call it main.py for just now so we don't mess up our existing agent. So I'm just going to import now from wasmtime a few things. Well, specifically, it's going to be store, module, and instance. And they're going to allow me to load up that WebAssembly text format file manually. So I'm just going to say store is equal to store, and then I am now going to have module is equal to module dot from file and store dot engine. Don't worry about this too much here. And then I'm going to have math.wat. Now remember, I put that in my tools folder, so I am just going to need to say it is in tools at math.wat there. And then I need an instance of this. Again, this is very similar to the JavaScript code that was created by AssemblyScript. And we're just going to equal that to instance. And I'm going to pass in the store, the module, and we just need to have an empty imports in there. And then finally, I need to export out my square function. So I am just going to say equals instance.exports. I'm going to pass in the store, and then I'm going to pass in the function that I want to access, which in this case is square. And then just to make sure it works, we're just going to print it out and make sure it comes back with some sort of answer. So we're going to say square of 5, and that should equal, and we'll put %d in here. So now we've done that, if I just clear this and I do python main.py, you can see it's square of 5 is equal to 25. And then I can change this. If I say square of 3 and we pass in 3 here, we should now get 9. So the cool thing about this is we are now using Python to call our WebAssembly module. Now, what specifically is happening under the hood is actually loading the square.wat file. So it's using the WebAssembly text format. is then doing the compilation to create the instance. Once it's got the instance, so it's created the WASM file, it's exporting out that square function, and then it's allowing me to execute and call it just like any normal function. So that's pretty cool so far. We've got Python able to call our WebAssembly functions, but actually I want my agents to be able to do that now as well. So we're going to come back into VS Code for a second. We're going to come into tools here, and I'm going to create a new tool, and this time I'm going to call it a square tool. So we'll just call square tool.py. And then this time, rather than doing this multiply here, what we are going to do is we are going to replace that with our square function from WebAssembly. So I'm just going to delete this. I'm going to set this equal to square. And then I'm going to specifically copy all this from main.py. And then I'm going to bring this into my square tool. Now, there's a couple of changes I'm going to need to make. Now, you see here where it does print square equals 3. I'm calling square, but I'm passing in my store here. Now, I don't want to do that. I want to be able to make normal calls. So to make this work, I'm going to change this from, rather than just passing in the name square, what I'm specifically going to do is I'm going to create a nice little lambda here. And I'm going to set the parameter a of the lambda to accepting square. And we're going to change this to square function just so we can make this a little bit separated. And now I can pass in store, and I'll pass in a here. So that is now, rather than calling this square function directly, it is now going to specifically wrap it in a lambda, so I can just call square normally. Now, also to make this work, I need to give it a name. So because the function is a lambda at this point, so it doesn't have a name. So I'm just going to give it the name square_tool. And now I can get rid of this print statement because I don't need that anymore. So I'm just going to give it the name square_tool, and then that means that the agent framework is going to be able to see the square tool and use that when it's looking for it. I don't need this print statement anymore, so I'm going to get rid of this. Now, if you remember in our tool definition, you see this kind of pedantic description where we say add 2 integers, which helps the agent understand what the function's doing. I kind of need to do the same thing in my square tool. So what I'm going to do here is I'm also going to set a description, and I'm going to set that equal to calculates and returns the square of an integer. Now, obviously, I want to do the same for the parameters as well. So I'm just going to create a new class called square params. I'm going to inherit that from base model. Now, if you remember from my square function, my parameter name was int. And then what I need to now do is be able to provide a description for that parameter because I haven't defined that within my WebAssembly module. So to do that, I'm just going to use field. I'm going to pass in the parameter, and then I'm just going to add a description. So it'll take all the properties that it's got today already. We'll add a new property called description, and I'm just going to say the integer to be squared. Now, as you see, I've got a couple of squigglies in this case, so I'm just going to add from Pydantic base model, and I need to do the same for field, and therefore I've now correctly imported base model and field from Pydantic. So that looks pretty good. So now my parameters that I have defined my WebAssembly module, I've added a description to that, and I've obviously added a name and description to the function. Now, if I save that, if we come back into my agent.py now, and then I just add a new tool. So we'll say from tools .square tool, and we will import square tool. You can see that's came up with a square tools not accessed there. So I just need to change this from multiply tool to square tool, as I've forgotten to do earlier. And now I can just add square tool to my tool list here. And then rather than asking what's 25 plus 5 multiplied by 2, I can just get rid of this and I can say square 10. And now, rather than running our main.py, if I do python agent.py, you can see it's came back with the square of 10 is 100. So I've now got my agents calling WebAssembly. This is pretty cool so far, right? But I think I can go a lot further than this. So I think one of the things that we can now do is actually we could dynamically load tools. So I'm going to create a new file called tools.json. And what we'll do within tools.json is actually dynamically define what the tool is. So in this case, we're going to have a function called square tool. You see the description is going to be square as an integer. The WASM file, in this case, is going to be called math.wat. The exported function we're going to use is square. And then here's a parameter, which is a type integer, and the integer to be squared. Why is this important? Because that means I can dynamically load my WebAssembly. I no longer need to have that hard-coded anywhere. I can just dynamically load my functions. So you can start to imagine that if we implement this, you could have a massive tool directory, kind of similar to kind of NPM, where you list all the tools that you need. It's got a description of the parameters, and then you can just pass in whichever tool that you can use, do some function calling on that, and then it's just going to work. So to make this work, one of the things that we will now need to do is we're going to need to take that square tool and we need to modify it so it's a little bit more dynamic. So we're going to call this dynamic tool.py. And now some of the things that we need to get rid of is that square parameters isn't going to be much use to us because that's really hard coded to the function. So we want to be able to dynamically kind of load that. The store is going to remain the same. And now one of the things that I want to be able to do is be able to get a tool by name. So I'm going to create a new function called get tool by name. And what we will do is pass in the name of the tool that we want to load. So we're going to say name is of type stir, and then I'm going to return a function tool. So one of the things that we are going to want to be able to do is I want to loop through the tool section and then load every single tool that's within that. So to do that, I just need to create a nice little for loop, and I'm just going to loop through all the tools in the config section there. Now I haven't already loaded my JSON, so I will just add that in here. So I will just say with open, we will say tools.json. We'll say as f, and then I'm just going to say config is equal to json.load f there. Make that nice and easy. I'm going to have to import my JSON at the top here, so we'll do an import JSON. So now that we're looping through the tool sections, if it's the tool config section, if the name is equal to the name that we passed in, we're good. Now I could just bring this within scope here. And now rather than manually specifying the WAT file, I can just say tool config, and we can pass in the name of the WASM file. And that means it will pull the WASM file from here. And remember, this is in the tools folder, so we just need to do / tools math.wat. So it's going to load this from here. So we've got that specified. The instant doesn't change here, but rather than calling it square.wasm, we'll call it wasm fn. And again, similar here, where we do an insert exports is we don't want to pass in the function hard-coded as square. So again, all I'm going to do is have a tool config, and we are going to look for the exported function name. And again, if you look here, exported function should be equal to square. So this is just happening dynamically. Now, like before, I need a wrapper so I can get rid of that store thing, similar to the lambda that I've got down here. So I'm just going to call that tool underscore fn. I'm going to pass in a, and it's going to be of type integer. And then that's just going to return wasm fn. So this function that we've got over here, and we're going to pass in the store. And we're going to pass in parameter A, and that wraps it up so that we're not having to pass the store from the agent perspective here. Now, rather than doing that kind of class for the parameters, I actually need to dynamically load my parameters here. I'm just going to have a nice little parameters model here. So I've got param name, and then I'm just going to loop through the tool config in this params, and then I'm just going to create a nice little dictionary of params. So all it's really doing is looping through this, and then loading it into my params variable here. And then I've got this thing here called dynamic params. And then I'm going to call create no model, pass in the name and the parameters. And again, if I just click on the squigglies here and add from pedantic create model, that is now part of it. So that handles the descriptions of the parameters. And then now, rather than setting square tool, I just need to return function tool. I can now set my fn to just being tool fn rather than having that lambda function. I don't need to worry about setting the name because it's now got a name there. And description here, I just need to set to tool underscore config, do get. I'm going to pass in description. And of course, if I can't get it, I'll just default that to an empty string there. So I now have a dynamic tool. And if I come back into my agent, we can now go from tools.dynamic tool import get tool by name. I can now do a lookup of the tool. So I can say matched tool is equal to get tool by name. And we will pass in square tool. Now in my list, I'm going to get rid of all of this from the list. I'm just going to put match tool. And now we'll just say square 5. And now if I run Python agent.py one more time, it will now do a lookup. And it works. Square of 5 is 25. So I've passed in my name. I've dynamically loaded it. There's nothing hard coded. I am dynamically loading my WebAssembly functions. Now, if you think about that for a second, that is pretty wicked, right? I have in here a nice little JSON file that describes my tool, square tool. Square is an integer. It determines where the WAT file is, math.wat. You can think about this. I could load this from a database. I could load this up from a big WebAssembly directory in the sky. I say what my exported function is, square. It will then compile it, run it. I say what the parameters are with the description. And then the model is able to, understanding through the magic of function calling, how to interact with WebAssembly. This is just game-changing stuff. You can imagine whole massive directories of tools up on the internet that we can simply just use. And I think we are going to see the sort of NPM of WebAssembly for large language models coming soon. And I think that's going to be one of the next big projects. That's one of my big predictions here. Now that that's working, of course, and again, it's all sandbox and it's safe, so it's very, very cool stuff. But of course, I am manually defining my tools at the moment. You see, I'm doing match tool, get tool by name. If I wanted to be super cool, what I could do is RAG search this, right? So if I had a big vector database with a list of all the tools, I could just do a RAG search on this and then find the tool that I want to use rather than specifying that. So that is what we are going to do now. So I am just going to come back in here. I'm going to create a new folder. I'm going to call it data. I'm going to be super lazy. I could put in the JSON file and etc., but I'm just going to do this really quickly. So I'm going to create a file called tools.txt. And then all I'm going to do here is I'm going to have text separated lines, which is tool name, square tool, add tool, multiply tool, description, square is an integer, adds two integers together, returns the result, multiplies. In reality, I want to be able to use the JSON capabilities of LlamaIndex, but for speed's sake, I'm just going to list all the tools here. And then what we can now do is look that up. So if I come back into agent and I just add in a couple more imports, so I'm just going to do LlamaIndex.core, and I'm going to specifically import a vector store index, and I'm going to take a simple directory reader. So all I'm going to do is read whatever files in that folder, i.e. that text format. And then I'm just going to load documents. So I'm going to say documents is equal to single directory reader. I'm going to pass in the data folder name, and then I'm just going to ask it to load whatever data is in that file. Now, specifically, as I said, I should be passing in a file name. In the future, we could have an entire vector database up in the cloud, but I'm just reading files very, very quickly to demonstrate this point. And then I need to index it. So I'm going to say vector store index dot from documents. I'm going to pass in the document that we've got here. Now I'm going to move my query up here. So rather than saying square 5 like this, I am going to, let's put square 7. And then I'm going to pass query down here. And what we are specifically going to do now is we are going to pass this query into our vector database and ask it to look up which function we need to use. So to do that, we need to be able to query those documents that we just loaded. And to be able to query the documents that we just loaded, I need a query engine. So I'm just going to specify query engine is equal to index, which is our vector store index that we just created of all the documents. And then I am just going to say as query engine, call query engine dot query. And I'm going to ask it, give me a list of tools that I can use to satisfy this query. I'm going to pass in the query that we just defined here, which in this case is square 7. And I'm telling it to just return the tool names. And with that, it is going to look at that tools.txt here that we have. It's going to take the function square 7 and it's going to look through this list and work out which tools will be able to satisfy that. Doing the vector search and using retrieval augmented generation, the LLM is going to help figure out what that final list of tools is going to be. So I should get a list of tools. So now all I need to do is do a tool name is equal to stir response. Now, of course, if I wanted to return multiple tools, then I would need to do a little bit of a kind of loop through that and then get a list of the tools and iterate through that and then look up each tool individually. But for easiness sake, I'm just going to query on a single tool. And now rather than calling get tool by name and then passing in square tool, I can just pass in tool name here. And then below that, nothing else changes. So now if I run Python agent one more time, you are going to see rather than me manually specifying this, it's actually taken the query square 7. It's looked up our database and then it's calling tool fn dynamically and it's got the square of the function. And now if I wanted to, I could, rather than calling square, I could just pass in something different. I could say 25 plus 7. And now I could run my agent one more time. This will error because I've not specified the add tool yet. So we get an error there because it couldn't find a tool there. That's fine. We will come back into my tools.json. Though I've defined it in my tools text, I haven't defined it in my tools JSON. That's okay. I'm just going to copy the square tool there. We'll put a comment in here. And now I'm going to add tool. And we'll say adds to integers. Remember, I had already defined this in my math.wat there. We're going to say the exported function is add. And in this case, I need 2 parameters. So I'm just going to put in b here. And we're going to say the integer to be, the first integer to be added, the second integer be added. So now all I need to do is change this from square 3 to 25 plus 7. If I just run this here, you are going to see it's going to have a bit of a failure. And the reason is I've changed the number of parameters. You see it's got too many parameters given 1, expected 2. So all I need to do now is if I come back into my parameters for a second. So if I go to dynamic tool, now if I just extend this to have A and B, and of course I need to pass through B here as well, and then I run this again, you can see it's now passing through 25 and 7, 25 plus 7 equals 32. So there's probably a little bit of more work here that it would need to happen to be able to have a dynamic wrapper rather than it being hard-coded to the parameters, but you kind of get the point. So I'll probably update that for a future video, but all I would probably need to do is pass through quarks, look at my sort of parameter name here, pass in the dynamic parameters for the tool function, and then we could have something that's completely dynamic. And then again, if I come back here, change this from being 25 plus 7, put this to 25 multiplied by 7, or even say 25 multiplied by 7. We run this one more time. As you see, it comes back with an error. So again, all I need to do is extend this in tools here. So rather than having an add tool, I just add in my multiply tool now. We'll just paste this in here. We'll say multiply tool multiplies to integers. It's using the same math.wat because it's already in there. We'll change it from add to multiply. And we'll say multiply. We'll clear this, run this one more time, and it should be able to multiply the two numbers together. And then you see 25 multiplied by 7 equals 175. And of course, if I come back to this agent, added to 7, save this, and it came back with 32. So now I have a completely dynamic tools.json file here. You can imagine that, as I said before, WebAssembly central, up in the cloud where all the functions are defined. You just pull in a WebAssembly file that you need. Of course, there's a little bit of work that I would need to do on this tool function here, but this is super secure, it's sandbox, etc. I really think this is going to be the way forward. So I think this sort of RAG directory of tools up on the cloud, where you can dynamically load what you need and then have the agents be able to call the tools and have this massive function tool directory. Again, there's a little bit of work that I would need to do on that kind of wrapper there, but again, I'll maybe do that in a future video. Now, of course, I've shown you this with OpenAI, but of course, this is equally going to work with Mistral and the new function tooling piece. So again, I'll probably do another video on this. But anyway, I hope you're as excited as I am. I genuinely think that this is probably going to be the way forward. I think WebAssembly is going to be the function calling mechanism of AI. I think it's going to be the standard way to do tools. And this idea of a big RAG sort of NPM style database where you can just go look up whatever WebAssembly text files that you need or WASM files, pull that in, and then be able to execute those tools. And that's probably going to change the way libraries are done in programming languages forever. Anyway, I hope this video has been useful. I'm super excited about this, and I'll catch you in the next video.